We have several very important stories about Tesla to share with you today, and I guarantee you will not be disappointed. First, Larry Ellison, CEO of Oracle and provider of massive data centers for Tesla, was interviewed recently, and he tells a story about how he and Elon Musk convinced Jensen Huang of NVIDIA to sell them the GPUs. Second, ever wonder why some companies are able to create breakthrough products and others cannot? Well, Tesla's lead engineer for the Cybertruck shares what makes Tesla able to invent and innovate. This comes after it was discovered that the Cybertruck audio system actually uses the C-pillar as a sound chamber. He also shares several more examples of Tesla's innovations. Third, BMW is in major trouble. They just now announced a recall of 1.5 million cars for a braking issue that will cost more than $1.1 billion to fix. This isn't just an ordinary recall. This is a significant shock. Joining us today for these stories is Jeff Lutz. His background as a multi-decade supply chain executive and chief quality officer. He's now CEO of his own high-tech manufacturing consulting firm. Perfect for this specific story. You know a lot about how companies, if they have communication between departments, you can create real innovation. You've done this quite a bit at the top level executive. Before that, though, let's start with Larry Ellison. Fantastic story here of how he and Elon convinced Jensen Huang to at least reserve some, if not sell them the most, GPUs here. You and I have been saying for quite a while, about 6 months ago in January, we need to buy as many as we can. So this is Larry Ellison. He was interviewed. Let's listen into his interview. Before I get into the 4 minutes as video here, do you have any comments on this?
NVIDIA is making most, if not all, the profits right now in AI, and there's a reason for it. And the one thing I think people miss, there's many things, but the one thing people miss is that they actually developed, this is 15 years in the making, developed their own coding operating system for bringing up and instructing the GPUs. And you can't just make these, you need the software to go with it and the ability to architect software to do this work. So I think people miss that NVIDIA is not only selling hardware, they're selling software and capability well beyond CUDA, their software platform. I think that's one of the things that's missed when they start thinking about, well, they're going to come up and they're going to bring up. Yes, over time, some of this work is going to transition from the training side to the inference side, where some of these other OEMs may have more capability, but there's a couple of years for this to still play out, and NVIDIA's a very strong player, and you'll see it in this video in terms of the demand. The other realization I think you'll find, and I think it's important for people to be aware of, is like if you think of this like a gas gauge, it's nowhere near. It's still running on fumes and empty in terms of the amount of GPUs and processing power needed to operate these models in the future.
Yeah, this is the quote that's going to be fun to listen to. Yeah, Larry Ellison says, I went to dinner with Elon Musk, Jensen Huang, and I would describe the dinner as Oracle and me and Elon begging Jensen for GPUs. Please take our money. No, take more of it. You're not taking out enough. We need you to take more of our money, please. I just wonder when this dinner happened. Let's listen into his interview.
Dependency on AI. By 2029, I can guarantee you AI is not going to be the problem. Because the simple phrase, the race goes on. And I mean, this is like Formula One. What do I mean by that? It's really not one winner. I mean, you got 3 people on the podium, but it's really kind of one winner. Someone's going to be better than this than anybody else. And multiple people are trying. And there is a race. If you listen to Jensen Huang, and I'm sure you do, I know you do because I've seen his stock price, and I know. I went to dinner with Elon in Nobu, Palo Alto. I went to dinner with Elon Musk, Jensen Huang, and I went to dinner, and I would describe the dinner as Oracle and me and Elon begging Jensen for GPUs. Please take our money. Please take our money. By the way, I got dinner. Please take our money. Take more of it. You're not taking enough that we need you to take more of our money, please. It went okay. It worked. I mean, we yeah. I mean, the demand for GPUs, the desire to be first, the desire to build the most capable neural network in the world, getting there first is a big deal. Whether it's getting there first in self-driving or getting there first in reading cancer biopsy slides, getting there first in synthesizing video and making movies, or I mean, but there's this impacts so many. Doing protein design, build design. I mean, we're very involved in designing both small molecules and protein, much larger molecules, peptides, proteins, for cancer therapeutics, designing cancer therapeutics. I mean, being first is very important. And the guys who are in this race are very smart, and they understand they need to be best at something. They'd like to be first. So they're spending a lot of time and a lot of money begging Jensen. We're building data centers. I mean, my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up, but it's not. You need a lot of power to power acres of these it's acres of these GPU clusters. I'm not sure. Has anything like this ever happened before? You know what basic stakes is? You know what it costs to build a frontier model? Anyone know over the next three years? Yeah. How much will be spent if you're one of the companies that want to build a frontier model? You know how much will you spend? Anybody? Anyone want to guess? 10 billion? Anyone? 100 billion? Yeah, 100 billion. That's going to get you in the game. Put down your 100 billion. You ever see Molly's Game? You come in and you say, here's my money. Okay, it's not Molly's Game. It's a bigger game. Put in your 100 billion, and you're in the race.
Okay, that's Larry Ellison. He's the CEO of Oracle. Oracle is a partner of Tesla's. In fact, the data warehouse that Oracle's Tesla's been using, a lot of it is Tesla's Oracle. So that's why they met. So I love the fact that he said that it worked. This conversation that they had with Jensen. So that means that Tesla plus Oracle together is at least one of the leading, companies. It takes $100 billion. So that means that it's only going to be a few, but at least Tesla is one of them. What'd you take out of that?
Yeah, he's saying $100 billion, for a model. So you think multiple companies are going to need to do this. He said a lot of things in there. I thought were fascinating. Not everybody's going to get, to the finish line, and the costs of play in this game are really high. So you think about it, how much Tesla has spent and XAI have spent already, and how much more there is to spend over the next couple of years. You see that they're going to have to start really throwing off tremendous cash out of the business, even more than they're doing today, to fund this, or they're going to have to go out and raise more capital or some combination thereof in both of its businesses. You also see them getting together, Tesla working with Oracle. Again, you're kind of pooling together demand, because Oracle builds these systems out for other people, and they're doing it for Tesla. Tesla works with others as well. They work with Dell, they work with others, but you can see that there's some aggregating happening in supply chain, where you can aggregate some of this demand and then have a bigger voice at the table. So that's why, Jensen doesn't take dinners every night with every CEO of every company. There's hundreds of companies that are buying this product right now. So obviously Elon and Larry Ellison are going to be able to have that voice. I've seen some of these situations, and I've been in some of these situations. I've been at some of these during major technology transitions. We're going from, to 3G or going to 4G in mobile, for example. And when you're doing a lot of these transitions, there's a lot of uncertainty in demand. And there's also there's technical issues bringing up new technology where the ramp isn't always very smooth. And then you get in this mode of global allocation, which is where NVIDIA is with Hopper and where they're at with Blackwell. And you asked a really good question earlier of like, what are some things that people may not be aware of? Another thing with Blackwell that people may not be aware of is that NVIDIA is actually taking on more of the network and more of the system in terms of components in Blackwell versus Hopper. So there's more integration occurring, and they're getting, the consumer is getting, in this case, these OEMs, they're getting significant price, processing power, a huge boost over H100. So there is going to be this natural progression to want to get onto Blackwell from a power consumption, from a space perspective, as quickly as possible. But they have this they're in this unique position right now where there's so much demand just to get the models up and going so they can eventually be on a path to monetization, that consumers will take as many H100s as they can get right now. So H100 and Hopper, they're probably at their peak, maybe for the life of the product, of where they'll be from a gross margin perspective and efficiency perspective. And Blackwell's probably at the worst point right now because it's just ramping. So Blackwell's going to be higher cost for them, lower yields for them in the beginning, but then they'll work that out, and they'll be in a good position. That's why you actually saw NVIDIA in the last quarter, their gross margins went down from 77 or 78% down to, I think, 74%, and people were clutching their pearls. That's normal in an early ramp period for a new product, and they said it. I'm like, as soon as they said that, I'm like, that's Blackwell. And then later on the call, the CFO and or Jensen said, yep, that's because of Blackwell and startup on Blackwell. So anyway, this space is unbelievable. I think every time pundits get up on TV and say, well, this could be the point here, or they could signal something here, they're not in these conversations. And to me, there's a disconnect between what analysts know and how well informed they are and what these tech titans are actually doing and what they actually need. And some don't even know the extent of what they need. They're just trying to, there's a bigger downside to not having a lot of compute power in the beginning. So the question and I'll wrap this up, is what everybody's asking: is this just going to be another cycle where there's going to be oversupply, inventory buildup, and then what do we do? What people are trying to guess is, where are we on that cycle? And I would say we're nowhere near the end of that cycle. The question now that everybody's asking is, who's going to monetize this first and do it at an extreme, meaningful level? And that's the question in everyone's mind right now.
Oh, I mean, you just heard Larry Ellison saying it's just the beginning, and you want to be first, and it makes a difference if you're first on something. So you had a comment that few people here probably remember, but I think it's very, very important that you, in another show, you said that there's a reason why when Larry Ellison and Elon Musk are talking to Jensen Huang, the Jensen will choose Tesla, will choose Elon. And the reason you gave was because, well, A, they've got the money, but B, they want to show that there's going to be an outcome when they,
correct.
Tesla uses this, they spend the money on these data ware, but there's going to be two very near-term actual use cases that they're going to use it that's going to return money, which means they're going to buy more. It's a guaranteed, much more guaranteed. You know this. You are a supply chain executive. You're a manufacturing executive. You've been on both sides of the table. This is what you were pointing out to people, right? Do you want to just talk just really quickly on that point? Because I think it's a very big one.
Yeah. What people were confused what Elon's doing with XAI and with Tesla, and then he's moving product back and forth between the companies, and I'm sure there's proper disclosures occurring of all that happening. People are confused, like, what is he doing? Why is he doing this? When you're in this mode of being on allocation, which is there is more demand than you can build product, what that allows NVIDIA to do is they have to do a very uncomfortable thing, which is they have all these customers, they like their customers, but then they actually have to tell customers, like, you're going to get it first, you're going to get it second, you're going to get it third, or basically this is how much product they're not going to say where they're ranked per se, but they're going to say, this is how much you're getting and by when. And they've been in this mode for a couple of years now. And Tesla, and when you're on the NVIDIA side of this equation, supply chain 101, one of the things that you're trying to do is you're trying to reduce the size of your network latency from building silicon all the way to your inventory locations of your customers. And what you want is you want the fastest cycle. They call it a cash conversion cycle. And you want the fastest cycle of your product being made and your product being consumed on the other end. Mm-hmm. And if this is why Elon's very public about, look, we built this data center in 19 days, or in 22, and from day zero to this, we got this data center up and running. He's letting his partners know that he's very serious about speed and consumption, meaning like if you send me product, I'm going to get it up in operation and doing compute work very quickly. And if you're the supplier, if you're the NVIDIA in this case, you want customers that move with speed, and you want certainty of demand. And when you think about Elon, you think about his products, you think about 7 million Teslas by the end of this year. I guess 7 million will be the number on the road with AI perception silicon. Now that's Tesla silicon. That's a Tesla TSMC relationship. But the point is Tesla is getting real product out in the real world, and they're pulling what NVIDIA is shipping, and they're getting it up and they're getting it operational very quickly. And what does that do? That kicks off the next cycle for the next set of orders. So think about customer B and customer C for NVIDIA. Is it taking them double the amount of time to bring up their data center? And then if it's taking them longer to bring up their data center, then how quickly are they reordering and getting more product back in NVIDIA? You want the customer that consumes and reorders quickly and keeps that cycle going. And that gives you the most certainty in supply. It gives you the best cost structure. It gives you all the best economics. And then, I think Elon's profile on the world stage from being an innovator, technologist, that also helps. So in an allocation discussion, he is going to have tremendous leverage over this with this NVIDIA relationship. NVIDIA has the leverage, be very clear, but of all the customers, he's going to be in a very good position. So is Mark Zuckerberg. He's buying a lot of product. So are Google and Amazon. They're going to have these are all the hyperscalers, but Elon may be very, very close to real rapid monetization, consumption, and reordering, and probably doing it at a rate faster than others. That's why he started later. And look at where Tesla plus XAI are in terms of GPU cluster size. They're right up there.
Yeah, we got some big stories to keep going. Thank you for doing that. That was a very important one. So Tesla won number one in the Gartner Digital Automaker Index 2024. This is second straight year. This is a Gartner study or award for which company is able to generate the revenue from its over-the-air software updates, the digital leader, I guess, digital automaker. It's Tesla. This next story, I think, is very important, right up your alley as well to explain to us. But why do some companies succeed while others don't? Well, it's because can they cross the barrier between different departments, and can they innovate when they do something like that? So Dave Mattson, he discovered something very interesting about the way the Cybertruck subwoofers are installed. Why is it that the Cybertruck's audio system is one of the most incredible audio systems out there? Deep bass. There's only two 8-inch subwoofers. Well, this is what he discovered. Here's the subwoofer, but what's really cool was that it looks like a simple ported enclosure. So it looks like a small little enclosure, and the port is gigantic. Not a great way to get a leaded bass. How does it sound so good? This is the secret. Look at this little hole here, enclosure. So they're using the C-pillar, the airframe, and they're using the structural pillar of the car to serve as some sort of enclosure for the deeper bass response. Typical vehicle use a ported design, which can be smaller, but it's tuned for specific frequencies, less controlled. Wes, who's the lead engineer for the Cybertruck, replied to him saying, that's a great analysis. This is what happens when teams work together to make the best product. He then explains Conway effect, which you know so much about. You've probably taught classes on that. Just before I get there, though, tell me what you saw here?
This starts at the top of a company when the CEO is very prescriptive about what they're looking for in terms of, in this case, it's, you know, it's probably some amount of really a huge focus on cost, but also performance and capability. And when they're very clear about what their expectations are, and they're also very clear of like, hey, look, I've slept on factory floors. I've now learned the hard way of the importance to be thinking about manufacturability, to be thinking about part reduction, to be thinking about simplicity of design. Again, not designing some specific porting scheme for the speaker where it's another part that needs to be integrated and then there's more space needed in the vehicle. No, let's take something that's we have today. We have this existing C-pillar, and let's use that and let's leverage that and see how that works. When a CEO is very clear, like when they give basically 3 or 4 directives to everyone around cost, around simplicity, around part reduction, around, and then the expectation to work together to get to those results, and then celebrating like, hey, this team worked with this team and we figured out how to do this. No one's ever done this before in a truck before, and when in those types of situations are celebrated, that starts from the top and then it permeates to the senior staff that reports into the leader, and then it permeates down to all the team members because they all want to produce results that work and fit inside of that construct. Finally, there's a good, I think, aerial shot of the Cybertruck completely torn down in a Tesla, area of the factory or garage somewhere. And I saw that, the team was tagging all the different parts. And this is I teach this process too, in terms of design for cost. Everything that they're doing at Tesla there's this foundation of integrated teams working together and trying to figure out, it's not the operations team's problem only. It's not the design that I have a bad design. No, if you have a challenging design, it's incumbent upon a cross-functional team, excuse me, to figure out how to make that design at the lowest cost and at the highest velocity. So they work as integrated teams. They don't work as departments, lobbying stuff over to each other. And that's the fundamental difference.
I love it because Wes shares 4 or 5 things that Tesla does that is innovative. And I love the way you just explained it. Integrated teams, cross-functional. This is the Conway Law that you pointed out to me. Wes said this. Have you heard of Conway's Law? It's an interesting observation about the root cause of why large organizations usually make products worse. In 1967, Melvin Conway wrote, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. The way that they'll design is you can basically figure out which departments are separated from which departments. When you think about any product carefully, if you see an obvious lack of integrations, it's usually due to an organizational social boundary. If you're working on a product, you should consider if organizational boundaries are getting in the way of optimal design. So a well-known example that everybody knows about is how the battery would be made separately from the structure of the vehicle to give it structure, to give it safety. And then they realized, well, wait, the battery itself could be part of the structure to give it strength, crashworthiness, torsional stiffness. And so that's what they did. We ended up with a super dense battery in a strong box-like structure, which was then installed into the vehicle, which had a nice space for it to mate into. No issues with integration. Everything fit together perfectly. And we met all of our product goals. One of the highest crash safety ratings, probably reduced weight, reduced costs. We had a box full of battery cells, so it was installed into another empty box-shaped receptacle in the body, a box in a box. When you simplify it down that far, it sounds obviously wrong. The 2 organizations had achieved their goals, worked together without friction, and the product met its overall goal. Okay. Some smaller examples, which I thought was really cool, was the chassis air suspension, which is used to pressurize the battery pack to prevent water ingress. Use something that's already existing to pressurize the battery pack. The subwoofer, which I just showed, they utilize the air volume of the body. And then centralized zonal vehicle controllers instead of many small distributed controllers. Doors which use the exterior surface as a crash intrusion beam. The pedestrian warning system used as a horn. The list goes on.
Yeah.
This is why he loves working at Tesla. This is why I love Tesla so much. It's like this kind of innovation you can't see from the outside, but it's all over the place.
Yeah, they're focused. All these things are focused on simplification, and these are things that can be done with integrated teams. There's a team that works on the motor. It's not just a electric motor design team. It's got people from the factory that are working on test, people that are working on assembly, people are working on supplier development engineering. It's truly a cross-functional thing, because what that team has a goal of, like, hey, I want an electric motor that's that's under $1,000 and it has this level of performance and it's got this size. The only way to get there is through an integrated team that's working together, and this broad thinking that connects the different parts of the car, but not by department, but by actual working as integrated teams. So this is really the only way to do this. A lot of legacy autos, just they're not structured to do this. You see some of them forming skunkworks teams, smaller teams, to work together to figure out how to just basically clean slate and figure out how to do some of the stuff. That's the only, if they're going to survive, that may not, they still may not have the economics for the rest of the boat anchor of the company to survive. But if they're going to make compelling product, the only way they're going to do it is by getting these small teams together. Some of the greatest product transitions ever occurred, by small teams working together. Some companies are really good at this. Some companies aren't. I just remember back in the early 2000s, Motorola was getting killed by Nokia from a volume perspective. Candy bar phone was selling very well. They did the transition to digital very well, and they got a skunkworks group together and to kind of go off site and figure out, like, what's the next big thing. And we said the next big thing was an ultra thin clam style folding phone, and that was the Motorola Razr. That was developed kind of by a small team, at least in the inception of it, off site. And then even the raw development of it was a small team in a small city in Illinois that developed that entire product. So small teams, small integrated teams really work well together. When you have these big teams, big expansive departments, each of them having department heads with their own goals, and there's no integration or tie up to the top, is when you run into these problems and you get these Frankenstein products and you get these things that don't hit it from a cost perspective. When there's clear accountability and there's clear direction on the top, from what, to me, again, this all goes back to what's the direction from the top. And I think they've got crystal clear direction in terms of what's important in product development and manufacturing. I think they get clear direction from the top.
Okay, great. Thank you, Jeff. So this leads us to the next story, which is BMW. Big problem that they have because they're so large. It took them 2 years to find this big giant recall for the braking issues, and you'll see why that is. So it took them 2 years to find the extent of defect behind this braking issue. They learned of the braking issue in June 2022. There's a recall of 1.5 million cars. Now, this includes the Rolls-Royces, sedans, and SUVs. This isn't just a regular recall, said Ferdinand Dudenhofer, Director of Automotive Research. Said this is a significant shock to fix this. It's going to cost them $1.1 billion, 1.5 million. So the weird part is it took them a couple of years to find it. Customers, dealers began complaining about it, this faulty brakes in June. And it wasn't until last month that they realized that 1.5 cars, and this is going to cost them big time. They did an in-depth review, interference affecting electrical signals sent through the brake systems. It's got something to do with the brake-by-wire that they were trying to do, a brand new significant tool. What's also noteworthy is BMW has been stepping up quality control among suppliers with a task force. They see risk more broadly. So now they go, okay, might be spreading even further. So I don't know what else here. The orders halt of sales and deliveries, and then the braking system was faulty. What's your thoughts on all that?
Yeah, I mean, as former chief quality officer, when you approach these situations, the first thing you want to do is you want to protect as many consumers as quickly as possible. So if there's a safety issue, if there's a functionality issue that would impact basic functionality, definitely safety, you want to get in front of it as soon as possible. You want to inform consumers as quickly as possible. The other thing, and it's interesting how long the process took. one of the other things you want to do is when you come out with your plan, you actually want to have a plan. Like if you have to redesign a part, you want a decent amount of work done on the redesign. You want to know that you can actually solve this problem inside of the given constraints. But there's really here a focus on speed and a focus on getting your consumer, if there is a safety issue, getting them to a safe place as quickly as possible and giving them as much information as possible during, as you learn and as you're aware of it. So I think that's what they're focused on here. This is going to be very costly. It looks like the fix is going to be quite intrusive in terms of what they have to do, but they didn't really get too much into it. But I'm just thinking the braking system would be quite involved in terms of what they may have to do. This is one of the reasons that, as I kind of shift back to Tesla for a bit in terms of their focus on reducing part count, reducing complexity to build vehicles, and shifting more and more of the control into software. So there's a greater amount of things that I believe Tesla can solve with over-the-air updates than others can because of this software-defined vehicle mentality that they have. And I'm not saying that this problem could have necessarily been fixed with software. I don't know the extent of it based on this article, but I like where Tesla's focused here in terms of shifting more and more control in the software. And then Tesla, in terms of taking risk, they definitely took risk with the Cybertruck in its approach to steering and all the other different things that they took risk on. But they took it on a low volume vehicle and they controlled the introduction of it. And that's what you want to do. When you look at some of these BMW vehicles, obviously the Rolls-Royce Spectre is going to be low volume. But some of the other models that were mentioned, there's going to be a decent amount of volume over a number of years that they're going to have to deal with. So we'll keep a close eye on this and see what happens. But, this is I would say a pretty precarious situation for them right now. It's a big number too, 1.1 billion.
Yeah. Apparently there's a rising recall of the supply chain. This is your space. This is why you're trying to, reduce the supplies, QA for them too. This is another example of the original story we did, which is the larger the organization, it is even worse when you have all the supply chains and other organizations underneath you. Thank you, Jeff. Yeah. That was great. Your background is right on track of all these stories. Appreciate you. Follow him on his X account, the Jeff Lutz. Thanks, everybody. Bye-bye.
Thanks, Herbert.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.